Hi class, so for chapter 4, I decided not to change any of the notes from what I had already posted in case you had already printed them off. So the first video was already done, probably most of you had already watched it. If not, go back and watch that one, of course, first. So we're going to kind of go ahead and go through the idea of this activity that we would have done when we first got back together as a class. So assuming you're at home, perhaps you have some spaghetti lying around that you could use to actually do this. This is really just to kind of first get you back in the idea of thinking about an equation of a line. So again, I do actually recommend trying to actually do the idea here is use like your piece of spaghetti. You can just use a ruler or some type of straight edge if you'd like as well. And try to draw your line on here as well as find the equation for those lines. So this is sort of like a little review of algebra class. So pause the video here if you need to, try to come up with those equations, and then come back to see if you agree with me. Now that hopefully you've tried coming up with these equations on your own, hopefully your line on this first graph would have looked something like that. That would have connected all of these points together. Again, trying to kind of do some review type stuff from an algebra class. So we would need to find the slope and the intercept. So for this one, the intercept would have actually just been 0. And your slope hopefully should have been 2/3. Because you would go up 2 for every 3 that you went over. Up 2 over 3, up 2 over 3 to get that equation. Now, even though you don't really need that plus 0, it's just a little reminder of what that intercept technically would be for that equation. Now for graph 2 over here, hopefully your line would have looked something like this. So this one had a negative slope. It would technically cross the y-axis right here at 9. So that would be our intercept that we would have. So I know it's a negative slope. And I know that my intercept is a positive 9. Here my slope would be, I would go down 2 and over 1, down 2 and over 1. So that would give me a negative 2x. So again, hopefully just remember finding equations of lines. Now we're going to be doing a lot of interpreting in our class. So I want to make sure we feel comfortable with what a slope measures as well as what the y-intercept actually measures. So a slope measures what happens to y as x goes up by 1 unit. Now let's first think through that with both of our graphs up here. So if I move over only 1 block for x, I'm going to go up 2/3 of a block for y. 1 block for x, 2/3 up for y. 1x, 2/3 up for y. Over here, if I move over 1, I'm going to go down 2. If I move over 1, we're going to go down 2. So again, every time as we go up or to the right of x by 1, it's telling us either how much up or down we're going to go for y. Versus what the intercept tells us is what y is when x is 0. So that's really what a y-intercept is telling us. When x equals 0, what is our value of y? In both of our pictures that we have here, we can actually see exactly where that crosses our y-axis. Now I want you to try the same idea of trying to find an equation of a line with the following 3 sets of graphs. Notice how they are a little bit different than the ones that you had on the previous page. But first, again, just on these, try to draw a line that in your mind would be the best fit to those graphs. I'm only asking you to try to come up with the equation for graph 3. So you don't need to try to do it for graphs 4 or 5. So again, straight line, piece of spaghetti, put on your best line, and try to kind of have like a reason why you chose where you put it. Alright, so let's see if your line looks somewhat similar to the lines I've put on here. So with my graph 3, I'm hoping that first of all we would all agree that this would have a positive slope. No matter what, you have some type of positive looking line on your graph. It might not be exactly where mine is. I try to kind of split them in the middle. To try to come up with my equation here, I sort of try to ballpark about, it seemed to cross a point about perfectly here, which would have been 5, 4. And then here again as well as about 7, 7. So that kind of helped me come up with my equation that I have here. For graph 4, this one I would have hopefully had a bit of a negative slope going on with this one. And finally with graph 5, this one doesn't really have, it's not really a straight line relationship that we have going on here. So what was a lot different about the graphs here than what we had on the previous page? Well, on the previous page, all of those points perfectly fell on a line, right? So there was really no argument of where that line should go. But now here with graphs 3, 4, and 5, there sort of feels like some subjectivity of where you would put the line. But I'm going to guess, especially on graphs 3 and 4, we had a similar goal, that we were kind of trying to split the line down the middle, where we kind of had an equal amount of data on either side. But coming up with where you'd put that line was definitely probably harder than it was with graphs 1 and 2. And definitely come up with that equation was probably a lot harder than it was for graphs 1 and 2. So what is the idea that you should hopefully learn, or your takeaway from this activity? Well, what we learned in algebra class back in high school were what are we called deterministic models. So let's first understand what that is, since you probably have some familiarity with that. So a deterministic model is an equation that perfectly or exactly describes the inputs and outputs. And when you're thinking inputs and outputs, I mean, our inputs are basically those values of x that we've been plugging in, and the outputs are more of our y that come out. In a sense here, when I say it perfectly describes or exactly describes, we're talking there's 100% certainty in what's going on. And that's what we're used to from algebra class. However, that's no longer the case when we talk about a statistics class. In statistics class, we have what are called stochastic models. And what that means for us now is that now our equation has some inherent randomness. And by randomness, we're talking about the idea of variability. There is not going to be 100% certainty. And more specifically here, different data can give us different equations. We've talked in the previous chapters about taking a sample. So if I get a different sample, I could actually have a different equation. What I mean by that is think about this being 6 people's values that I described here. I could sample 6 different people and their points are going to look different. So the line that you're going to put on the graph could also look different. So that's how statistics is very different than algebra class. We're still going to have the idea of coming up with an equation of a line, but there's this uncertainty of, well, where exactly should I put that line? And then there's the uncertainty on top of that of what, well, if I have a different sample, my line itself could also look a little different. And notice that the points don't all fall on this line like they do in our algebra class examples. So this activity is to try to drive home the idea of what we're going to be doing is we're going to be working with now stochastic models, but we're going to relate the idea to what we've learned in algebra classes. So in the next video, we're going to talk in more detail about how we're going to do that.